Let's examine how to determine the minimum size branch circuit conductor required for a 10 horsepower, 3-phase, 230 volts induction motor using 60°C insulation. Firstly, we need to determine the motor current. We can use the formula current equals power divided by voltage times power factor times efficiency. In this formula, power, denoted as P, is given as 10 horsepower. This needs to be converted to kilowatts. 10 horsepower multiplied by 0.746 kilowatts per horsepower equals 7.46 kilowatts. Voltage, denoted as V, is 230 volts. Power factor, denoted as PF, is assumed to be 0.85 for induction motors. Efficiency, denoted as EFF, is assumed to be 0.9 for 10 horsepower induction motors. Plugging these values into the formula, we get current equals 7.46 kilowatts divided by 230 volts times 0.85 times 0.9. This calculation yields a motor current of 41.6 amps. Secondly, we determine the minimum branch circuit conductor size. We use the formula conductor size in American wire gauge equals 125% times motor current divided by ampacity. Here, 125% is the National Electrical Code or NEC requirement for motor circuits. I represents the ampacity of the conductor for 60°C insulation. For a current of 41.6 amps and using 60°C insulation, the ampacities of common conductor sizes are as follows. For 6 American wire gauge, the ampacity is 55 amps. For 4 American wire gauge, the ampacity is 70 amps. For 2 American wire gauge, the ampacity is 95 amps. Thirdly, let's calculate the conductor size using the previous formula. Conductor size in American wire gauge equals 125% times 41.6 amps divided by A, the ampacity. If we consider 6 American wire gauge, we have 6 American wire gauge equals 125% times 41.6 amps divided by 55 amps. If we consider 4 American wire gauge, we have 4 American wire gauge equals 125% times 41.6 amps divided by 70 amps. If we consider 2 American wire gauge, we have 2 American wire gauge equals 125% times 41.6 amps divided by 95 amps. Therefore, the minimum size branch circuit conductor required is 6 American wire gauge because a 6 American wire gauge conductor with 60°C insulation has an ampacity of 55 amps, which is greater than 125% of the motor's full load current of 41.6 amps. This calculation ensures that the conductor can safely handle the motor's current demand as per NEC standards. Remember that this calculation relies on several assumptions, including a power factor of 0.85 and an efficiency of 0.9. These values can vary depending on the specific motor. Always refer to the motor's nameplate data for accurate power factor and efficiency ratings. Additionally, this example uses 60°C insulation. If the motor terminations or the electrical equipment it is connected to are rated for higher temperatures, such as 75°C or 90°C, you can use conductors with higher ampacities, potentially allowing for a smaller conductor size. However, you must ensure that all components in the circuit are rated for the higher temperature. Always consult the NEC for the most up-to-date requirements and for specific details on motor circuit sizing. This calculation provides a basic understanding of how to determine the minimum branch circuit conductor size for a motor. Consider other factors such as voltage drop, conduit fill, and ambient temperature when selecting the appropriate conductor size for your application. Voltage drop occurs when the voltage at the load, in this case the motor, is less than the voltage at the source, such as the electrical panel. Excessive voltage drop can cause the motor to operate inefficiently and can even damage the motor. The NEC recommends limiting voltage drop to no more than 5% for motor circuits. To calculate voltage drop, you need to know the conductor length, the conductor size, the motor current, and the conductor material. There are various online voltage drop calculators available that can simplify this calculation. Conduit fill refers to the amount of space that conductors occupy inside a conduit. The NEC limits the percentage of conduit fill to prevent overheating and to make it easier to pull conductors to the conduit. The allowable conduit fill percentage depends on the type of conduit and the number of conductors in the conduit. You can find the allowable conduit fill percentages in the NEC. Ambient temperature is the temperature of the surrounding air. Conductors can overheat if they are installed in areas with high ambient temperatures. The NEC provides ampacity correction factors for conductors installed in high ambient temperatures. These correction factors reduce the allowable ampacity of the conductor to compensate for the higher ambient temperature. In addition to these factors, it is also important to consider the type of motor being used. This example assumes a standard induction motor. However, other types of motors, such as synchronous motors or direct current motors, may have different current requirements. Always refer to the motor's nameplate data for the correct current rating. Finally, it is important to remember that this calculation is for informational purposes only. Always consult with a qualified electrician or electrical engineer before installing any electrical equipment. Electrical work can be dangerous, and it is important to take all necessary safety precautions. Using the incorrect conductor size can lead to overheating, fire, and electrical shock. Make sure to always follow the NEC and other applicable electrical codes when installing electrical equipment. By carefully considering all of these factors, you can ensure that your motor circuit is safe and reliable. Remember to always prioritize safety when working with electricity. If you are unsure about any aspect of electrical work, consult with a qualified electrician.